Hey everybody, and welcome to another episode of Software Defined Everything, the podcast for smart world systems. I'm your host, Steven Onzo, and today I'm joined by Charles Cross, CTO for Mission Robotics and loyal RTI Connext user for over 10 years. Charles has applied Connext to his endeavors with autonomous vehicles, underwater and aerial drones, and now most recently in the marine ROV space with Mission Robotics. Charles, thanks for joining us today.
Yeah, thanks for having us.
In the time that I've been with RTI, which is just a little over 7 years, I've seen you work in the maritime ROV space, then applying your talents over to the autonomous vehicle space, and now back to marine ROV with Mission Robotics. Can you tell us what Mission Robotics is all about and the draw that underwater robotics has that made you want to return to this space?
Sure. I guess the drawback to the space is an interesting one. That's more of like a personal story there. I've got 300 years of history in the family of watermen, so fishermen, crabbers. So I've always grown up being on the water, and so that's been a core part of my childhood. And also part of that childhood, I grew up in like the era of the internet in the 90s, which was like a really fun time. Like things were not as constrained and more exploratory back then, and I fell in love with kind of the large online games, multiplayer, big exploring big worlds. And that's how I got into programming at a very early age. And I grew up wanting to kind of combine those two things together. And, you know, before getting into the marine space, I worked in like aerial robotics and other embedded systems robotics applications. And I found an opportunity, which was Open ROV, the company that I worked at previously, and we worked with Connext as well. Making a consumer underwater drone. It was like kind of the first of its kind. And that opened up this opportunity to apply the programming, the robotics in the marine space, tie everything together. And quite a lot of like the culture of that company was all about enabling exploration, which kind of scratched every itch for me. And it was a really exciting project and, you know, able to learn many things. The story of Mission Robotics kind of like started in the middle of Open ROV. There was a very interesting fork in the road that OpenRV had to choose. Do you make an off-the-shelf consumer product, or do you make more of like an industrial, you know, targeted platform? And for a number of reasons, we chose at that point in time the off-the-shelf consumer drone. It was something that didn't exist. No one was pushing the cost down. It was the whole play was to make things more accessible. After, you know, for a number of reasons, market related and otherwise, you know, that business model didn't actually pan out. Now that OpenRV merged into another company now called SoFar, doing really incredible work in like the smart buoy space and ocean monitoring. And after working in the self-driving car space for a bit, a couple of us from OpenRV got together and said, what if we, you know, turn the clock back and took the other fork in the road? And applied like everything we had learned, but like aerial engineering space and the underwater space and the self-driving car space, and brought that all back to the marine space again and took a stab at making more of a commercial platform. The reason why that was something of interest to us requires a little bit of context on the marine industry in general and like marine robotics. The best way I can describe it is like it is one of the most fragmented ecosystems and like industries like technologically that I've ever encountered. There are no real clear winners the way you have like in the smartphone space. You've got Apple and, you know, Google and things like that, and like in the PC space you've got Apple and Microsoft. There's no huge market share that any one company has, and you know, one of the contributing factors to that is like there are so many different problems to be solved. There isn't one size fits all solutions that can broadly be applied across the space. And because of that, you know, one of the things that happens is there are a bunch of smaller companies carving up the different niches and creating their own full like end-to-end vehicle solutions to target end applications. And what almost always happens with these companies is they create a walled garden around that vehicle line. They very tightly control like what sensor, in a rational sense. It's a very rational process. They control what sensors are supported, what actuators, how you can change the vehicle, which is often very little. And you kind of are for anyone trying to participate in an end application, whether you're doing survey or trying to start something like completely new that hasn't been done before, you're kind of at the constraint back in like of the whims of those companies. And that was the thing that we kind of wanted to set out and change. And it's a very difficult problem because due to the way the industry is, all of the people who are creating sensors and add-ons and other pieces that like can be put like glued together to create a vehicle solution, there isn't a platform. There's no standardized way of communicating between any of these things. There's no all the different vendors like have different ways of adding new things on, often limited. And so if I go out and make a new acoustic sensor, there's really nothing common between all those different platforms. And I just have to choose something that kind of makes sense, and I hope that people are going to be able to integrate. And because of that, volumes are lower. The marine space is like a much more harsh environment in many, going deep, saltwater, etc. Things are more expensive. Volumes are lower, which also drives up cost of everything. And so there really hasn't been the same push to standardize interfaces and communication protocols the way that has happened in many of the other industries. Like we see in self-driving cars, there's this is why we're talking about DDS and why we use it. It's part of the big story there. So that's where we step in. What we wanted to do was change that equation. We encountered a number of smaller players who had very interesting verticals they wanted to enter. These were people who were either wanted to do an in-survey task, like they want to actually perform the service, or they had a unique vehicle concept that they wanted to try out to target an end application. And they all had a common set of problems. The open source solutions out there for underwater, vehicle software, weren't cutting it for them. They were, not robust, not being able to last for, 24/7 missions, over weeks period of time. There are a lot of problems, and they had to, in order to work with open source stuff, you kind of need to have an engineering team of your own, software engineers, etc., that can pick it apart, find where things don't match what you need them to be, change them. And these customers were just running into walls left and right, and still are today. There are many aspects of this problem that we try and solve, but we can't solve all of them. But what we wanted to do was make it so that there were a set of building blocks, compute, sensors, communication interfaces, and all of the software pieces to be able to change the equation from people dealing with point releases of vehicles, or you buy this vehicle, this is the small envelope of what it can do or how it can be changed. Changing it from that, and maybe 3 years later someone will release a new vehicle that does something new or enables a new capability, to being able to do continuous integration. As soon as a new sensor comes out, it is able to be plug and play, added into the vehicle platform, any vehicle platform that is running essentially the software framework or uses the communication protocols that we've built around. So in a way, you can describe what we do is we build an operating system. We call it Nader OS. It's a collection of software elements that all use DDS to intercommunicate. It handles everything from the lowest level controls up to piloting and data services and stuff like that. Everything is built around DDS. So one of the things that we've tried to differentiate around is there are companies out there, competitors that do provide extensibility theoretically through their software interfaces, but they're not standardized protocols like DDS. And what we wanted to make sure is that if you built a system, a solution on top of our system, we did not want to be the blocker for you being successful. We didn't want you to feel some degree of vendor locking, we need to, we want to hold you as a customer and have a good relationship, but we don't want to block you. If we can't go and write a driver for a specific sensor you want to use, that shouldn't stop you from being able to do that. So all of the sensor interfaces are all DDS interfaces. So if you want to add the latest and greatest or have us do it for you, that can be done. Any of our software elements can be disabled and replaced with their equivalents, just matching the the programming interface or the DDS interface. So that was kind of how we've shaped up our technological solution to address that problem. And so far, what we're seeing is that it's been very successful, and we have now gotten to the ability where we've deployed to many, many, many different types of vehicles, all different kinds of configurations, numbers of thrusters, sensor types, and we've even stratified. Some customers are very price sensitive, so they can pick out of our toolbox a la carte of I want the driver for the embedded cheap MEM sensors, or I want the very expensive tens of thousands, hundreds of $1,000s complete INS solution that's survey grade. And all of that, plugs into like our control system and state estimation system, which is then common across all these different vehicles, and also give them like a control interface, like piloting interface and that sort of thing. And so that's been really successful to meet this wide variety of needs. And we've learned over time that there's also a hardware element to this problem. We knew there was part of it was access to compute, and we didn't think we were going to go into this business to become a hardware company necessarily, mainly a software exercise. But customers are also having trouble designing the actual hardware systems. You've got a waterproof, pressure-proof, noise-proof, all these different things you have to do. And so in addition to like us trying to remove the element of you needing a software team to design your vehicle, we've also found that all these companies need help replacing the need for electrical engineers and technicians and hardware integration aspects as well. So that's where we've been growing into, and we're approaching this state. We've reached many aspects of it for certain use cases, being able to provide all these modules and building blocks that are used in a consistent way. And the goal is to get to a situation where you can scale your end product, copy paste this solution to every single vehicle you build the same way, and get to a situation where you can scale to hundreds of vehicles, and not have to worry about the integration pieces. Just hook all the bits together and away you go, and have the comfort knowing that to stay competitive in the market when new capabilities become available, either because we've designed new software capabilities like autonomy or AI applications that can plug into our system, or a new sensor or actuator comes out, there is a path to integrating it, and you're not going to have to wait 5 years for some other company to, make it possible to use that on a vehicle.
The last thing you said there kind of leads into my next question. There's so many use cases for underwater robotics, and I'm sure your customers are looking to do a wide variety of things. Is there a common goal that your customers are trying to achieve, and how is Mission Robotics helping to accomplish that goal?
Yeah, that's an interesting question. There are some customers that are very singularly focused on an end application and an end customer. We kind of divide our customers up into two main types, integrators and end users. The end user is the person who is going to be using the vehicle to actually go and do a job. This could be a services company. This could be, one of our largest customers that's most successful, or one of our most successful operations. They do 24/7 multi-month long missions doing oil and gas and energy pipeline survey applications, and so they are someone who actually uses the end vehicle. Then the integrator is the company that is designing an actual vehicle. So they are taking parts off the shelf, the various sensors, they're building a frame, they're putting the thrusters where they want for the end application, and they are either targeting a specific type of user with the vehicle they're building, or they're targeting a more general platform. So some of our integrators that we work with build just a very standard frame that can be used for multiple different purposes, and some of them are building vehicles that are hyper-focused on a specific thing, like in aquaculture, doing a specific type of asset repair or maintenance or inspection task. And the thrusters are in certain places to enable certain types of movement. So it does vary. I'd say there are three main classes of end use case that I think most of our customers are targeting right now. That would be asset repair and maintenance is kind of one of them. So actually physically interacting with an asset. Inspection, so just general inspection survey. A lot of this is trying to go from divers or, once every year or once every few year operations to using robots to do them many, many times faster, cheaper, more effectively, gathering better data. Some of this is mapping, but a lot of it is tied in the commercial space to asset inspection, making sure things are, pipelines are still in good health and nothing's no holes in anything, that sort of stuff. And then the last thing, which kind of falls under maintenance as well, is cleaning. Aquaculture nets, ship hulls, dry dock, lots of different surfaces that need automated cleaning. It's a very dangerous and dirty job, very expensive for divers, and there is a very heavy shift away from doing those tasks manually. So the sectors that we are generally involved in tend to be kind kind of like these commercial, like aquaculture is one, general like energy applications, so oil and gas, wind is becoming a bigger one, inspecting cables that are running out to wind farms, things like that. And then a smattering of other smaller industries. Kind of our approach to this is to plant seeds with these individual small integrators or end users and learn more about the end industries and see what the big opportunities are going to be, what applications are good for scaling, which ones probably aren't ready or doesn't make sense to invest the effort in. So we've been trying to plant seeds in each of these different spaces and others and pick the best opportunities to help these end customers scale. And how we've tried to divide the responsibility is our customer, direct customer, is responsible for understanding the end user, understanding their needs, making sure the vehicle is like designed the right way, making sure they understand like what factors of the business model to that customer like matter. Like, is it reducing time on the water? Is it getting divers out of the water? And then for the like understand like what the pilots need to actually do the job. So we rely on them for that. And then what we cover is like all the technical underpinnings to make sure that our integrator doesn't have to worry about things like breaking in the field, doesn't have to worry about software not connecting, not working. A lot of these litany of problems that they've run into in the past, either trying to build things in-house on a shoestring budget or using off-the-shelf open source stuff.
A statistic that always stuck with me is that us as humans have only explored about 5% of the Earth's oceans, and that alone makes the marine industry fascinating. But with that, there's its own challenges, right? How is Mission Robotics addressing these challenges as you navigate through a completely new environment than, say, a autonomous vehicle on the road?
Right. Yeah. So just to kind of give listeners a good idea, like the marine environment is very different. So there's a lot of shared commonality, like common problems between an underwater robot and an aerial robot or a self-driving car. Everything has issues like figuring out where I am, making sure everything communicate properly, understanding the noise and like error in your sensors and, adding like fusing all of that together to get to a good understanding of where you are. And then of course, all the control aspects for any given vehicle. Those are common. What happens in the marine space is that you make a few of those problems exponentially harder. You don't generally have access to something like GPS. Salt water specifically, like water is a great attenuator, probably perfect almost in terms of blocking electromagnetic radiation. So you don't have GPS underwater. You don't have like things like Wi-Fi, a lot of like even visible light. There are ways to use laser and other other light-based technologies like LiDAR, but they don't go very far. They don't produce as good results as with self-driving cars. A lot of that, makes us fall back to acoustic sensing. So, using sonar systems like sound travels much better through water than electromagnetic radiation by far, and so that's kind of one of the primary sensors used to get information like ranges to objects, your velocity of your vehicle. So there's a device called the DVL, Doppler Velocity Log, that gives you kind of the body velocity of your vehicle. These are all things that are much simpler problems to solve simply because there are sensors that exist that give you direct introspection of those types of data in the other spaces. Then you have the added challenge of like everything has to be packed into smaller enclosures. They have to be waterproof, pressure-proof. You have to get power to all these things. There's cabling concerns that have to go everywhere. And so like everything is just harder. Software, electronics, sensors, everything becomes more difficult. What we've been trying to do to address that is basically creating this toolbox of validated drivers and solutions for each of these different types of sensors. And that makes it easy to incorporate, like I said, the latest, the best versions of these things that are possible, and also kind of plug and play them into any design. But then we take it one step further, and we've developed our own state estimation solution that is generalized to be able to take in all these different pieces of information. So, in any given vehicle, you might design something like a Kalman filter to take in specific sets of data of sensors, and some of the open source solutions can take in, a handful of the variety of these types of things. But a lot of the open source solutions were founded, or they're based around aerial and ground vehicle projects. And so there are some concepts of underwater, sensors like DVLs and acoustic sensors that they aren't properly accommodated by those platforms. So we've made a state estimation solution that can tie all those in together and, kind of level up the playing field in terms of what any general vehicle can do in terms of understanding where it is in the ocean. That's kind of the story around sensing. In another aspect, like connectivity is also a rapidly changing field. And, I think we're doing a lot of work there to make sure that, vehicles can intercommunicate with each other. They can, talk potentially over the internet, do remote operations. There's a big shift towards that. And that's another way that we're, kind of changing the way in which these vehicles can operate. And that is allowing us to move towards more autonomous, more distributed, heterogeneous fleet applications that let you start doing much more challenging things that haven't been able to be done before.
I've heard you highlight the lack of interoperability in the marine industry. Can you touch on that a little bit and how you're working to overcome that?
Right. So as I mentioned earlier, we're in the situation where, OEMs and sensor vendors and any device vendor really has no guarantees or of compatibility on whatever platform they're working on. So there is no standardization for almost, every application. Most of these vehicles that you encounter are this hodgepodge mix of serial lines, I2C, SPI, Ethernet, CAN bus. And that's just like the physical interconnects. Across all of those, there's no common protocols or ways of exchanging data that tie everything together. So what you end up having is you've got kind of the traditional situation of vendor makes a specific sensor or payload. They give you a data sheet and maybe an SDK. A lot of these companies don't have software resources, so sometimes there is an SDK. There's just some documentation. You've got to figure it out. And then it's left to the integrator to figure out how to wire all these things together, how to get their data integrated into various pieces of software. And the result of that, because it's hard in many cases, is that these elements don't directly integrate together. One of the most common things we see in vehicle solutions is, let's say you have a navigation solution or like a multi-beam sonar used for mapping the ocean floor. The data from those systems today, in most cases, unless you have a company that's taken the steps to do the proper integration, they are usually not going into software, being fused or used within the navigation or operational aspects of the vehicle within its own software. They're usually running up a separate network connection to a completely different computer, usually a laptop sitting up on top that's running a specific vendor's viewing application, and it's completely separate from everything else going on in the vehicle. And so that's where it's an unacceptable situation, and it's really held the industry back. Not only in terms of the capabilities of vehicles, but also the data side of things. All of these vehicles should be able to produce data that other applications can build on top of, and have them in standardized formats. One of the biggest pieces that's missing as well, even in the open source space, is there aren't any agreed upon data file formats that time synchronize all these things together. The solutions you've seen to this traditionally, on ships running ROVs that have many different of these types of sensors, gathering multi-beam data, is they've got a server rack with some proprietary system that company has done the job of making a box that you can plug in all these different types of hardware solutions, and they've done something to tie all that together and put it into a single file format, usually proprietary, and then they can export to different formats. But that takes up a lot of space. It's not hardware that's necessary. All the processing that we're talking about can be done on a microcontroller these days, even like a Raspberry Pi. It's not rocket science, and it doesn't require a ton of performance. All it requires is standardization around data formats and communication. And so that ties into our story. We're using DDS for everything. And then we're also building capabilities like record and replay and analysis that are built around open file formats. So one of the protocol or one of the standards that's emerged in the robotics space in recent times from a company called Foxglove is a recording format called MCAP. And MCAP was designed specifically to target the needs of time series data, like distributed topic-based time series data created by robotic systems that have many different disparate sources of data that all need to be correlated in time. They need to be able to replay that data back into systems. It needs to be able to be read by many different programming languages and tools and frameworks so that you can actually do analysis on it post. It's the primary back-end recording format for like the ROS2 ecosystem, where it kind of got its popularity and its start. And so now, rather than having all these disconnected sources, we have all of the sensors that are able to talk directly into the vehicle system. So it also doesn't even have to go up to the surface. We can have smarts on the vehicles, which enables autonomy. And then once it gets there, we can record that into a single file that has all of the data contained in a parsable, non-proprietary format that then others can build solutions and new innovations on top of just the data alone. So there's two pieces of it. One, making all of the data sources talk together in real time to enable real-time capabilities, and then making sure the data is standardized and accessible for applications after it leaves that vehicle.
So you recently gave a presentation to RTI at our headquarters, and in that presentation you mentioned with Starlink, the ocean is opening up. Starlink is definitely a new technology for getting connection in remote areas, and I think a lot of people see it as high-speed connections for rural areas. But it also opens up a lot of new business opportunities. What do you mean by your statement about remote connectivity, and what opportunities and possibilities does that potentially create?
This is one of the most exciting things that got me back into the marine robotics space. When I joined OpenROV, we're kind of at this point in time where cell networks were ubiquitous. You were able to do real-time connections between like the video calls, and there was some like video games. You could start playing a game remotely on a different machine across the internet. And one of the founders of OpenRV posed to me like, what if you didn't need to own a robot? What if you didn't need to be at a location where there's water? What if all you needed was like a smartphone or a computer and an internet connection, and you could explore the world? That was like kind of a transformative thought for me, and also like kind of one of those things that ties together like the interest in gaming and exploration and robotics. And I became very fascinated with like remote teleoperation and remote control of systems. Also, just like thinking about how we control rovers on Mars, and like the time differences and things like that, like the ability to do one-to-many operations that teleoperation opens up. That has traditionally been an extremely difficult problem in the marine space because there's no infrastructure generally that provides real-time, sufficient bandwidth and sufficient latency to do real-time communication to systems that are out in the ocean. There's been some support for doing operations near shore where you can focus, Wi-Fi or LTE, other types of radio based solutions out into the water. But in general, teleco operators don't face their antennas out to the water intentionally in a lot of cases because that's not where a lot of people are. So there's a lot of gaps in coverage, and that's just along the coast. With the introduction of these low Earth orbit like satellite systems and bringing internet to anywhere in the world, whether it's Starlink or some of the other options that are emerging, that radically changes the entire equation. Before that, basically, the only options you have are some of these higher elevation satellite systems that you can get high bandwidth out of. They're very prohibitively expensive unless you are a large company, like some of these billion-dollar multinational survey companies, and you've got kind of fine control over the quality of service of your connection, guaranteed bandwidth amounts, that sort of thing. And the amount of bandwidth you get is still very limited. You can't stream, tons of HD video from all the different cameras, and it's hard to, control things with guaranteed, low amounts of latency. The systems I've controlled that are running on those networks typically have 300 to 600 millisecond round trip latency, if not worse, oftentimes into second plus. So these new 100 megabit connections you can get anywhere in the world with under 100 millisecond latency, that changes what is possible. And we're seeing the industry want to adapt to that very rapidly. One of the big areas that ties into, as I mentioned earlier, is removing crewed vessels from operations. So I'll use one of our industries that we work with a customer in as an example. In aquaculture, there are these offshore nets, 180 meter diameter pins with salmon or whatever type of fish, and they need to be cleaned, inspected, repaired. Right now, there are divers doing most of that work. So a diver, let's say in Norway, is required to have a crew of at least 4 people on a boat. There's insurance requirements, hour working requirements. There's litigation or laws that have changed how that all works. So recently, the number of hours a diver can spend underwater in a day in Norway has been reduced drastically, and that has pushed solution providers, aquaculture, like the people who own the nets and the ROV services companies that are trying to fill the gap there, to want to take people out of the equation. So this involves the first step of you may have a boat that takes a vehicle out to the site, maybe 1 or 2 people on that boat that are just deploying the vehicle, no divers required, and you're using these remote connectivity systems to get a connection. Someone remotely pilots it, and they can do that to all the different nets that the company owns. And then the next step of that is once you have things like autonomous surface vehicles that can have the connection themselves and they have no crew requirements, that autonomous surface vehicle can carry the vehicle out, and now it can be done completely remotely. And of course, thinking along the levels of autonomy in the self-driving car industry, like getting to level 5 autonomy, once the robots are smart enough, you don't even need to necessarily have somebody doing the piloting. You've got a bunch of connected systems that can report when there are issues. So part of my experience in the self-driving car space was you had to design your teleoperations solution to match the capabilities of your autonomy solution. As autonomy got better, easier to trust, more mature, the direct control aspect of your teleoperation changed from being I'm directly turning a steering wheel, pressing on a pedal, to I'm drawing a path or I'm making a yes/no decision, turn left or turn right, for that mostly autonomous system. And we're seeing the exact same trajectory in the underwater space, which is being unlocked by the fact that now you can connect these things anywhere. And it's really changed. Like now you can have systems that are out in the middle of the ocean that you could never get a connection to before with this type of real-time connectivity. And once these vehicles have more capability in the autonomous space, you can do one-to-many operations that radically change how any given application or industry or exploration is performed. And so, your comment earlier about how much we've explored the ocean and kind of the situation and how it changes that, it's a little bittersweet. We're at the exact point in time where we're going to transform, probably within my lifetime, from having explored almost none of the ocean to having explored probably most of it, simply by virtue of the fact that these vehicles are going to be able to completely autonomously map the ocean floor. And there are many companies that are trying to do just that as their charter.
So clearly remote and constrained connectivity is crucial for your operations. How are you currently ensuring a reliable connection over these long distances and challenging conditions?
So one of the things that we learned from the self-driving car space, not learned, but we deployed and implemented these concepts, is that you can't expect connections to be 100% reliable. It's just not possible, and you need to plan for that. And many of the existing solutions out there, they either try to use completely reliable connections, like transmitting stuff over TCP, which has reliability built into it as a protocol, or using kind of standard configurations for video streaming, for these peer-to-peer solutions. So those are mostly best effort. So if you lose something, so what? It wasn't necessarily designed to target real-time control of vehicle solutions. It's more for webcam streaming and non-mission critical applications. The answer lies between those two elements, and part of what we have done is leverage the strengths of DDS to control the shape of our network, or of our traffic within our system. So within the vehicle, you've got high bandwidth data from your sensors. You've got large video frames, potentially uncompressed. Remotely, you only need a subset of that to understand the situational awareness of the vehicle and to and like you want your video compressed. You need to shape your traffic to the constraints of your network, which could be different in many different situations. And us as a platform provider, we need to understand the different scenarios. Like you have an excellent direct local Wi-Fi connection that you've perfectly built hardware-wise, no interference, all the way up to like you're operating over one of these 600 millisecond geosynchronous orbit satellite systems, and there's a lot in between. Cellular networks, and the your quality of service varies per each. So there's a two-step process. One is segmenting your vehicle solutions data. So the data bus, the various topics that you're publishing, you need a solution where you can carve those out and transmit that data only to the network interfaces and addresses that you specifically want them to go to at the frequencies and bandwidths and sizes that you need. And one of the tools that RTI provides that helps to do that is like the routing service, the Connext routing service, and that's one of the elements that we use to take care of that part of the problem. So that's one of the major pieces. The quality of service profiles that DDS specifically provides. You've got reliable, you've got best effort. The reliable protocols, they aren't the same as TCP. You can tune the reliability aspects. So you can say, I want to try for 200 milliseconds, and after that, consider the data stale because the remote system doesn't care anymore. It's too late. You can use best effort if you just want to make sure that, I'm going to try my best. Like if I receive something or if I miss something, don't try and resend it because that's going to take up my network bandwidth and I may not be able to afford that. So the quality of service profiles give you some very fine-grained controls over how and where and like the edge cases of when you send data, which are very powerful, and that's what we leverage to make sure that we can operate over these networks. One thing that a lot of people don't think about when using DDS, which the Connext Anywhere has solved with the WAN transport feature, is that it can be difficult to penetrate the network topologies across the internet and establish the connections that you need due to firewalls, corporate NAT traversal. So one thing that helps is being able to condense all of those network connections. So typically DDS, you've got many different programs within a computer that use many UDP ports, and each of these different programs needs to connect with each other. What you want to often do is boil that down to a single port and a single network connection, so that then you have to take special steps to be able to establish like a peer-to-peer or a relayed connection through the internet and tunnel that data from one side to the other, pierce through the different firewall configurations, network configurations. Sometimes it's enterprise, sometimes it's just a factor of the way like a cell network provider has structured their network and assigned IP addresses. So the combination of like routing service, which allows you to boil all the mini programs down to a single participant in the DDS network, and then the WAN transport API, which allows you to boil all of your DDS traffic down to a single port, a single network connection. That helps you navigate these complex network environments. One way we take it a step further on top of that is we've got this concept of best effort communication within the concept of DDS quality of service and reliable communication. And when you are transmitting a time-sensitive data stream like video or audio or some specific type of control signal that has very tight constraints around its operation, sometimes you want something in between those two cases, even more in between than the DDS tunable reliability configuration, which is that I want to try to send my data best effort, but I don't want to have any kind of round-trip communication to repair errors or to try again. I don't want to use any additional bandwidth besides what I am sending the first time. So there are techniques where you can split up your packets and do error correction, and kind of do ahead of time protection mechanisms for the packets you're sending, where if you get a subset of them through, you can repair the missing ones. And so some of those techniques are things we employ like in our video streaming, and critical like high bandwidth compressed streams, so that we don't have to do retransmissions across high latency networks or potentially highly lossy networks. So all those things add together to create the ability to efficiently deliver data in a reliable way across these networks.
I mentioned earlier that you've been a power user of Connext for 10 plus years, and trust seems to be a common theme here. Can you talk about why trust is so important, not only for you to trust the connectivity framework in your system, but also for your customers to trust Mission Robotics?
Absolutely. So this is one of those things where it has shaped our company and our company culture. When there are multiple layers of organizations interacting to ultimately provide a successful solution to an end customer, that end customer doesn't have visibility into the different layers that comprise the solution. When they see a problem happen, they're going to point the finger at like the first person that has provided them the solution. And what we've found is necessary is to build each layer of a solution on an absolutely rock solid foundation, such that you don't have to look back and question what you've built on top of. Our customers, our integrator customers, need that from us. They need to focus all of their energy and their capital focusing on the problem they're trying to solve, their payloads, their vehicle design, the end use case of the customer and their needs. And that customer wants to focus on the task they're trying to accomplish. And everybody requires trust that the piece they're building on top of the tool they're using is solid and reliable. And when it isn't, it creates chaos, mostly in the form of increased cost, increased time to market. Support burdens will balloon exponentially. And we've experienced this firsthand, and it's driven how we've changed interacting with our customers. We've taken over more of the complex technical tasks, like gotten more into some of the hardware elements, just to remove some of the uncertainties of the underlying platform that they're building onto their vehicle. We, as a platform builder, also have the same need. And we need all of our applications to be like, we don't want to be fighting with problems like our nodes can't discover each other, data isn't being delivered reliably. We need trust that like we're using this communication framework, and all of our data is going to get where we want it within the bounds of what we've specified. And all the tools that we use and pull into our solution, Connext included, we need the trust that those solutions are going to work reliably. We don't have capital or time to spend helping to debug or enhance like open source solutions and things like that to get to the point where they can provide that guarantee. And that's where RTI and Connext have been the perfect partner over the last 10 years I've used it. I made the comment, I think, in my presentation when I visited that I don't generally think about RTI or Connext in like my day-to-day, and that's how it should be. That's how any like vendor relation should be. Because when you're being thought of, it's because there's probably a problem. And we don't we want that to be the minimum. Like we're generally happiest when we don't hear from a customer for a few weeks because things are just going so well. And that's been an absolutely critical part of our business model, our ability to, we've mostly bootstrapped this company. We're not venture capital funded, much like RTI. We're built mostly upon revenue, and we don't have time to waste on solutions not working and like trying to, force open source stuff or poorly implemented solutions into submission and We've beat our head on that too. We've tried in certain areas and had dismal results, as we've talked about before. So trust is essential, and in your underlying components. And our whole model is don't build on top of like a foundation of sand. That way you can provide the guarantees to your customers that they don't have to worry about those aspects either.
You've noted RTI Admin Console and RTI Routing Service as two essential tools that your developers use. You mentioned Routing Service just a few minutes ago. Can you dive a little bit deeper and talk about how these tools enhance your workflow and enhance your overall system?
Absolutely. So RTI Admin Console, that's an easy one to talk about. That's just a portal into all of the data flowing through your system. Even non-engineers on our team, like non-software engineers that aren't writing DDS software, gain immense value from that because they can go in and see in real time what any individual node is publishing, see the status of the system. And with the latest version 7 of Connext, like now there's finally the feature that I've been waiting for a long time, where you can publish data directly from Admin Console, which lets you do fault like a failure, fault injection, and send control signals without even having to write any code. So that's just been like a big, kind of multiplier in terms of effectiveness for testing our system and seeing what happens when certain errors or messages come through that maybe shouldn't. So that's how Admin Console has been really useful. And it also lets you visualize kind of the topology of your network and see how the nodes connect together, which can give the team like a good sense of like how the system is architected. Or any DDS. So if you bring another DDS vendor or another vendor's tool, which is built on top of DDS or software element in, you'll get visibility into all of that as well and see how it interconnects into your system. So it's a good learning tool, and like grokking a system provides a lot of value and agility there. Routing service, as I kind of talked about earlier, is really important when it comes to defining the boundaries of the system. On these so we've got embedded compute systems like NVIDIA processors that are attached to network switches within the vehicle, and some of those network connections go out to the public internet or an enterprise network. Some of them are local to the vehicle, connecting to sensors or other compute elements. Routing service is what lets you basically put gateways in front of each of those network interfaces and make sure only the data in the exact format, quality of service profiles, goes to the network interfaces that you want them to. And it also lets you delineate your software elements, split them into different domains, make sure certain applications don't discover other ones, because the overhead of that, those interactions like cost bandwidth and CPU time, network traffic. So it's kind of like this, it's not quite right to call it a firewall, but it is exactly what it's called, a routing service. It is a router that makes sure all of the network, not just the network, but the software elements within any given system are talking to the right components and operating the most efficient way possible. It also lets you transform from one data type, like one data model to another, which has kind of become the way we've looked at how we're going to integrate with external DDS-based systems. You can't necessarily decide day one that all of like the definitions of your DDS data model, so your IDL types, in a way that everyone else is going to agree with you and it's going to be perfect, and that's what everyone's going to use. There are various standards out there that are emerging within the defense space. There's the UMAA, and they define their own set of IDL data types and services and software interfaces that we're using DDS. And routing service is also, it fills the role of being able to transform data from your internal design or your internal data types to those other types. Not only to DDS types, but you can also adapt to completely different protocols like REST requests or any other type of protocol that you can write a plugin for. And that's also where Connext has been powerful, is that for all the places where maybe RTI hasn't specifically provided a solution, like a bridge or adaptation into a specific protocol or whatever it might be, there are places for plugins and adapters that you can write yourself without having to rebuild the entire Connext foundation of libraries and whatnot. So that's enabled. You can write custom transport plugins to do some of the stuff I was talking earlier about efficient video transfer, and you can write adapters for the routing service that transform from one data model or protocol to a completely different one. And that's what we're leveraging and banking on for adapting to other standards and other types of messaging services without compromising on what happens within our ecosystem within the compute that we control and the software we write.
I know you've been a user of ROS2 and considered using it in past projects. We at RTI actually get a lot of questions about when and where to use ROS2 from customers and prospects. Considering the ease of use, it could be very tempting to see it as a quick path to solving some of the hard challenges that come with robotics. But I understand you've had challenges with that approach, and I think your experience could really help some of our users that may be considering such an approach. Can you discuss why you decided to revert to using pure DDS and what lessons you learned along the way?
Sure. It's been a bit of a roller coaster on that front, because we originally started with pure DDS as well, and for a specific project. We were doing some work internally for a new major release, a bunch of new features that we were trying to implement, and we did this experiment to try and implement that new release using ROS2. And we went into it with the expectation that there still might be, warts, things that aren't quite ready for production. We were hoping we'd be able to get through most of them because we waited until a point where ROS2 reached a release that was, very well into like the long-term support cycle, or, claimed so. And when we got to the point where all of our software was, functional and we were doing like autonomous navigation and things like that, all of the problems we were hitting were related to the ROS middleware layer. So this is kind of the abstraction layer around the DDS vendors, that, you can choose whatever DDS vendor you want. And one of the things that we were trying to do, because we know, certain customers are going to want to add new capabilities and write new software using the DDS vendor of their choice, we tried to make sure, one of the goals of using ROS2 was like, okay, we can use Connext internally, it meets all of our needs, like it's ready to go today. External parties can use whatever they want, hopefully because of the interoperability of DDS and like this framework that ROS2 provides, people will be able to like leverage ROS2 to like just plug in new components. Before we even got to that step of other people working the system, we tested with, even with Connext, all the different vendors to see what that experience was like. And we had a number of issues around performance, interoperability, regressions from one ROS release to the next. There's a lot of constraints we ran into around building for certain platforms. ROS2 is very heavily tied to like Ubuntu releases, or kind of tier 1 supported platforms that they target. It's tied to like system packages, like apt installing packages and that sort of thing for dependencies, and that made it hard to consistently build and deploy our system to Yocto images. And like there was work in the ecosystem to try and tackle some of these problems, but each of the DDS vendors was making improvements, but sometimes it wasn't even related to the DDS vendor's implementation of DDS. It was tied to an issue or a constraint with the middleware layer itself. One key aspect that is not addressed at all yet is DDS implements this concept of keyed topics, or keyed data types, and quality of service profiles are like mostly built around that concept. And yet ROS2, in an attempt to be abstracted from any specific type of middleware, they don't support the concept of keys. And so all of the best practices for like how, and like this also includes other types of quality of service profiles like partitions and things like that, you can reach down to them within the ROS2, like reach down to the middleware layer, get pointers to like the SDK of choice that you're using, and do some of these things on your own. Sometimes you can't because ROS2 has already done them, or interfered before you can. You end up basically having all the problems of like trying to use a complex DDS system, and now you've got all these additional problems and gateways and barriers and friction in front of you from the ROS2 layer as well. And we just got tired with our time being spent overcoming integration issues, and with our nodes not connecting to each other, or being unable to apply a very powerful QoS policy that Connext made available to us that we couldn't use in common standard like ROS2 topologies. So eventually we retired that approach and switched back to pure DDS, and then magically, in the same way, like before we went to ROS2, all of these problems disappeared, and we were back to focusing on the actual things that we were trying to accomplish for our customers. So, I don't want to, be negative about ROS2 on the whole, because it has a very valuable, it has a good value proposition in the sense that like it is trying to accomplish, standardizing and introducing conventions that allow people to collaborate and rapidly like glue together different pieces, be experts in different parts of the problems. The same thing that we're trying to do overall in our business, but from a technology readiness standpoint, and particularly from the viewpoint of we're trying to build a platform and target many different use cases and have systems where you've got many different vehicles potentially on the same network of different types and many different remote operators. What our kind of conclusion right now is like ROS2 works well within constrained environments, in terms of like the size of your network, the complexity of your network topologies, number of vehicles, the overhead introduced in some of these. It constrains your ability to get to these like very massively scaling systems without a ton of additional work on your side to draw all those boundaries and constraints. So if time to market is of essence and you don't have like a huge team to dedicate to solving all the problems in ROS2, filing bug reports, making PRs, helping each of the open source DDS vendors get to where they need to be to like do things that you can already do today, then it's not the right choice in our opinion. And that's why we switched back. And, like I said, with routing service and the ability to adapt to other, data types and QoS profiles and whatnot, you can bridge to ROS2 systems without compromising on your ability to use all the features of DDS within your system. And that's how our strategy has changed. It's not that ROS2 is not an appropriate component or it doesn't belong in the solution. It's that there's a better way to integrate it in without having to over-constrain your entire system design to what it allows you to do.
Building on top of that, I want to ask you about open source options for DDS. A lot of projects start with open source DDS, but then a lot of them turn to RTI once the project enters a new stage. The system becomes more evolved and more complex, and there's a need for additional functionality. Can you elaborate on some of the specific challenges you faced with open source DDS and how it impacted your operations?
Yeah, I'll try and be as diplomatic as possible here. And I want to start off by saying, I truly believe that the open source DDS implementations are good for everybody. I think it is very important that they exist, even though we're not using them today in our business application. There's specific reasons for that, but open source in general, having competing implementations with different focuses is healthy to any ecosystem or standard. There shouldn't be one company or that controls or implements everything. People need options, and it creates healthy competition. The specific problems that we ran into, and I'm not going to tie it to a specific implementation or anything like that, but if I looked at my inbox where I get all the subscriptions to the daily PRs and issues and things like that for each of the different implementations, there were such common regressions and things that impacted us directly to race conditions, memory leaks, sudden crashes, data types not being interoperable or serialized correctly on the wire. The one thing I depend on DDS to do is in a standardized way get my data from one place to another. And at the time that we tested these and used these, which I've been doing it off and on, taking the pulse over the last 5-6 years, ever since I started this effort back around ROS2 dashing, which I can't remember which year that was in. That's when I started to take it, pay attention seriously and try and use each of them. They can't be fully relied upon for the level of robustness that I need. And so we've got customers doing 24/7, 60-day missions, doing, oil and gas pipeline inspections offshore. And I can't have a situation where programs are crashing because, there's a bug implementation. And that's not to say that, Connext has no bugs or any individual vendor has no bugs. All software has bugs, but at least my experience in the last 10 years is I've never experienced a bug of that type of nature or a regression of that type of nature. And the interoperability and the ability to upgrade versions and move stably has never been invalidated or violated. And that was what was most important to us. In addition to just stability and frequency of bugs, there's also some sentiment in various parties of I won't say disdain, but lack of desire to fully adhere to the standards that are laid out by OMG for the DDS specifications. Sometimes that leads to just outright interoperability, which is kind of the worst possible thing. You want to use DDS because you want interoperability. It's great on its own as a standalone solution, but you're probably using it because you are expecting to integrate with other DDS applications that you aren't writing. That's one of the main points. And so when implementations don't fully respect the standard and create situations where interoperability isn't possible, then that kind of erodes trust in DDS as a whole, but also, that specific implementation. The other thing it leads to is certain features just not being prioritized or implemented, whether that's the dynamic data types or X types 2 and XCDR2 and things like that. And so if you're trying to build tools that depend on those features, you don't even have freedom necessarily to jump around between different vendors or implementations or use them in a consistent way, because one vendor will implement all of the things and you've built your tools around that, but then another vendor hasn't caught up to that point yet. And so, and also if they're not interoperable in terms of like how they exchange, information about their types and whatnot, like admin console won't work with other, certain other vendors necessarily because they haven't implemented certain, transmission of data types. And so all these tools are becoming siloed in their various ecosystems of the different vendors. And the promise of interoperability is lost. And your promise of like not being able to avoid vendor lock-in or whatever it is that, is being advertised is not true. As I said, the most important thing for us with our customers is accelerating, like one of the most important things is like accelerating their time to market. And, part of that is building on top of like a robust solution and all that. But we really need the ability for all of the we're trying to make it so that like both the communication between applications as well as the data formats are all standardized. And like, so functions like recording and replay and routing different networks together, all of those pieces need to work. It's not like kind of a take some here, take some there, like it's all or nothing. And to that point, like if time is of the essence, your team doesn't have any resources or you have no desire, like it's not your business to help other open source implementations catch up, then our recommendation and our decision was to rely and choose Connext DDS, or it makes more sense, say, micro or whatever makes sense for your application. But that's the value prop and the trade-off that we look at there. I expect them to become more mature over time. I expect them to be more interoperable as customer demand forces so. I've already heard some promising things about better interoperability between Connext and Fast DDS and that sort of thing. But I think it's going to take time, and we want to solve the problems today, not whenever those things get straightened out. So that's kind of like our perspective on that issue. I will say, like, one of the exciting things that it has accelerated is the access to DDS from other languages that weren't necessarily like immediately supported by any particular vendor. So, Rust being opened up, new implementations and bindings targeting that. That's kind of an exciting space, and that's what I was talking about in terms of like driving innovation and driving competition. That's what I like to see from them existing and moving forward.
How does having out-of-the-box tools, libraries, and SDKs offer a better experience than the offerings of open source for a team that may be evaluating a connectivity framework solution?
I think that if you're going to be using a connectivity framework, I've had experience with different companies that tried to home roll new middlewares or like clobber together various different pieces to create something that looked like a middleware. And in those systems, you got kind of one or two situations. Like it's a double-edged sword. If you do it poorly, if your public APIs and your libraries and what your communication framework does not meet all of the needs that you have as an organization, and you're only given kind of a closed like SDK by your vendor, then you are pretty constrained in terms of like what you're able to do to modify it to meet your needs. How the networking works, like the underlying wire protocols and how data moves around, the data types, it's all standardized. So that's in that situation, you want a concise, consolidated SDK, assuming it implements all the features that are laid out by the standard and what you need as an organization. And at that point, having the best documentation, having the right tools, all of that is an acceleration factor for your team to be able to work effectively within whatever it is. If you have the need to modify and extend beyond like what we're talking about, like transport, like plug-in kind of capabilities, if you need to fundamentally change how communication happens, then of course like you need access to like the open source elements. But I have worked with vendors in the past that created their own solution using open source components, but then wrapped all of that with a proprietary SDK that can be modified, and that ended up being a dead-end solution. And of course, in those situations, sometimes the answer was to move to DDS at the various organizations I was at. So I think that's my thoughts on it. If you've done everything that you've said you're going to set out to do, and like customers can clearly evaluate this standard meets my needs, then having the most compact, concise, well-documented, tool-rich ecosystem is what your customer wants. And it's what we wanted, and it's like what we leverage on the daily basis with the various tools and capabilities that like Connext provides.
Well, as we wrap things up, let's talk about the bright future for Mission Robotics. Looking ahead, what are some of the key trends you see shaping the future of the marine technology industry, and how is Mission Robotics in a position to help lead towards that future?
One of the concerning but interesting trends that we see right now in the industry is that, at least in the, as I'll say, like the North American, the American side of the industry, is that a lot of the investment and drive is coming from defense applications, and that can be a positive thing. It can be a negative thing. What we're seeing, because going back to what I said about it being a fragmented and kind of chaotic industry, everybody's built their little castles. Everyone's kind of defending their niches and vehicle solutions and whatnot. When all of the money is coming from defense applications, it kind of takes the air out of the room for other industries and fields. People it's not very common right now to see a lot of VC, Silicon Valley type venture capital come into the commercial application space in the marine industry. It's harder to raise money. It's not like other industries. And a lot of the money, as I said, is coming from defense applications. There's, this American dynamism kind of movement. You've got the conflicts in Ukraine and other parts of the world that are driving marine-specific technological innovation for defense purposes. And so all of the players who are providing solutions to the market, at least from this side of the globe, they are shifting their focus to defense applications. That's the bigger opportunity. That's where the money's coming from. If you're, a smaller, like doing something specific in aquaculture, sorry, we can't focus our resources on you. There's this, hundreds of millions or billions of dollars doing this other thing. So you've got companies like, Anduril and all the various defense contractors that play in the space. That is very clearly where they're moving, and so a lot of that's built on top of DDS too, and DDS has been like a big kind of element of the defense space and tying all these disparate software components together. But we see it as an opportunity. We see it as like players are turning their eyes away from the commercial space. A lot of customers are very dissatisfied right now with all the solutions they have because everything's so behind, everything's so fragmented, nothing's interoperable. Customers who have good connections and good opportunities in specific verticals, but don't necessarily have venture capital to build the team to do it, or don't have the teams or expertise, they kind of have no options right now. And we see that as an opportunity to change the way the market works, change the way this industry operates, and support all of these various players to test their ideas and get into these new markets without having to be dependent on defense money. I say that's one of the biggest trending things we see. On the positive side, there is an extremely strong demand for interoperability, like for all these reasons, and common data formats and time synchronized recording of like disparate systems. And also on the hardware side, one of the things we're involved with that I mentioned, the company so far, Ocean Technologies, they do the smart buoys. They have spearheaded a new protocol called Bristlemouth, and I won't get too deep into the details, but the closest analogy I can think of is like, imagine what USB did for like peripheral devices plugging into computers in a standardized way. It's the same thing that's being addressed in the underwater space. New, cheaper, more capable connectors with common data like protocols and connectivity between all these different sensors, turning all of those UARTs and I2C and various Ethernet and other protocols into a common IP-based communication stack. That standard is one of the examples, and we're involved in the protocol design for it, and very strongly pushing to make sure that it can interoperate appropriately with systems like DDS and other like named data network protocols. Those types of efforts are going to be radically changing the industry in the sense that it will be lowering the barriers of entry for players, and that's of course like exactly what we're trying to do as well. So I expect over the next 10 years, like that is going to be the biggest shift we see, is that the barriers to entry are lowered, interoperability becomes king, and a lot of these large players that refuse to move or refuse to open up or whatever it is, like they're going to lose market share, and smaller players are going to get a chance. And that's what we're banking on.
There's been so many advancements in the underwater industry, but at the same time, it seems like things are just beginning.
That's absolutely true. And that's the case for us too. Like the level of problems we're solving with customers right now are just getting the basics of their application working, like being able to try the new thing, like the new repair mechanism for whatever industry thing they're trying to repair, or being able to fly a specific type of vehicle to do the job necessarily, like to observe whatever they're trying to observe, like inspecting the face of a dam, like autonomously, like that's just the beginning. And like there's so many applications that once you have that core framework and platform and interoperable like communication endpoints, that opens you up to all the advancements that are happening in other industries around autonomy, AI, computer vision, machine learning. It's just a start, and we're trying to be sprinting at the starting line, and many people haven't even reached the starting line yet. So there's going to be a massive shift, and it's going to be a very exciting time for innovation.
Who knows? We could have this same conversation 2 years from now. It could be a completely different discussion.
I expect it will be.
Well, with that concludes today's episode of Software Defined Everything. But before we go, as always, I'd like to ask you one last question. What's one recommendation you have for our listeners? It could be a book, a travel destination, a restaurant in your area, even just something you think that is worth sharing to our listeners.
One of the projects that we worked on was is a project to create a vehicle that could efficiently map a coral reef. And part of that, we got to travel to Tahiti to do on-site testing, which was exciting. And it was my first time traveling to a coral reef and getting to snorkel and dive on a coral reef. And we went to the place where, someone's like, this is the best beach to go dive on. This is the spot. You're going to see all this coral and, all these fish and sea life. And while doing that, I happened to swim over the edge of this reef and found myself in the middle of just a completely dead coral reef, bleached, like everything. There was no life, no fish swimming around. And now having a daughter, I think about this so often, the change in our environment, the change in our world, and the disappearance of like these reefs, not just coral reefs, but many different types of habitats and life. I encourage people to go and see these places, not just the fun places with like I said, all of the sea life and like the beautiful reefs. Make sure you see the parts that are falling behind or dying off, the things that are at risk. I've found through the work that I did at Open ROV and continued work in through Mission Robotics, it's hard for people to form the desire, a care for something that they don't see. And that was kind of the whole premise behind, what if we could put these robots in the hands of everyone, get them connected to the internet, and like you could open up the world in all these environments and their beauty to people who had never seen them before. I encourage everyone to go and make the effort, if possible, to do that, and expose your children to it, to like kind of create that future where people have a chance to care about these things that we're losing.
That's amazing. Well, thank you, Charles, for joining us today. It's been an absolute pleasure, and we hope to have you on again sometime in the future.
My pleasure as well. It's been an honor. Thank you so much.
Thank you.